Welcome to the project demonstration of lab sensor based light and fan intensity controlling system. So here we are going to control the intensity of this AC bulb and speed of this AC induction motor based on the clock inputs to this sound sensor. So whenever the one clock was detected, then the level of this AC induction motor and the bulb intensity will be goes to level 1. So same time second clock level 2, third clock level 3 and fourth clock again is come to the 0. So like that, so 1, 2, 3, 4 stages will be controlled based on the input signals from this one. So here this mic condenser interfaces to the LM358 comparator, so which will amplify the data and convert that into the digital signal. So means the analog signal will be given to this microphone and it will provide us the analog output. So the comparator will compare the data and amplify that. So LM358 will act as a two ways. So in two modes, one is the op amp, another is the comparator. So one op amp will be amplify the input signal to the millivolts, and that operational next comparator will convert that analog signal to the digital signal. So whenever the clamp detects, it will provide us the 0. Till that it will keep on providing the 5 volt. So based on this trigger signals to the A4 pin of our PIC16F73 microcontroller, so we have coded that in embedded C language based on the trigger pulses. So if it is a one trigger pulse triggers the controller, then we need to increase the intensity of this AC loads and like speed of this AC induction motor, that will be controlled through the BT136 triac through the MOC3011 after the diac one. So here we are using this zero crossing detector to detect the AC signal zero crossing point. So after that only we need to control the triac firing angle. Based on that we are going to control in 4 levels. Means here, as we know that AC signal consists of 50 Hz of frequency. So in that each pulse consists of 20 millisecond. In that 10 millisecond is the positive waveform and 10 millisecond for the negative waveform. So the positive waveform need to be controlled. So we need to know the when the positive waveform starting, means when the positive waveform crosses the 0. So that will be identified with the help of zero crossing detector. So it will take the 12 volts AC input from the transformer. So we are providing 230 volts AC. This transformer will step down the 230 volts AC to 12 volts AC. So that is a parallelly input to the regulator power supply board and zero crossing detector. So coming to the zero crossing detector, so this DB107 IC which will act as a rectifier circuit, so which will convert the AC to pulsating DC. So from there we are going to dividing the voltage which can trigger the transistor. Means whenever the 0 crosses, the transistor will get switched on, and whenever it comes to the 0, so it will be switched off. So this on off signal will be converted to the square wave signals after this transistor. That is the main input to the B0 pin of our microcontroller. So when we switch on the power supply to that, so this regular power supply board consists of 3 stages. One is the rectification, filtration, regulation. So rectification will convert the AC to pulsating DC. Capacitor will remove the pulses, and after that we will get the 12 volts pure DC voltage, and this regulator will step down that 12 volts DC to 5 volts DC voltage. So that's the main source input the microcontroller. When you get the 5 volts power supply, it start reading input from the microphone, the mic condenser sensor, sound sensor. Based on the sound detection, so it will check the programming whether the first or second or third or fourth. If it is first, then it will increase the timing angle, firing angle to this BT136 by 25%. So second again 50% and 35% again 100%, nothing but coming to the 0 again. So like that we are going to control the firing angle to this. So coming to this triac board, there we can use the two components. One is the diac and another is a triac. So this diac is used to control the triac used to trigger these two loads. Means controller will give the signals to the diac will give the signals to the triac, and triac will allow the power supply to these two loads. So let us see demonstration. So this is the reset switch. So when we restart the microcontroller, so this light will be on and off 2 times. When it is off, okay, we should keep the hall in silence. First 1, 2,